All right, this is part 2 of section 5.1. Let's go ahead and find the vertex and the line of symmetry for this function here. So notice that this function here is in standard form. Okay, so standard form is this form right here, and from that form we can go ahead and find the vertex as long as we have a negative inside right here. Okay, if not, we're going to have to change the function just a little bit. So notice we don't have a negative inside here, we have a positive. So I have to write this as negative 3x minus negative 2 squared plus 5. Have to have this negative right here so we can find our h value. So here our vertex is negative 2, comma 5. Okay, so the way to remember this is basically you are taking, if you are in this form, inside here you're taking the opposite sign of what they give you. If they give you positive 2, then your h is going to be negative 2. If they give you negative 2, then your h is going to be positive 2. But for your k value, it's whatever they give you. They give you positive 5, well, your k value is positive 5. They give you negative 5, then your k value will be negative 5. Okay, and your line of symmetry will be x is equal to negative 2. Now, to figure out if the vertex is a maximum or a minimum, for this form, you look at this number right in front of it. Because it's a negative, this should be a parabola that's opening downward. So here's the graph of that function. Notice how it is a parabola that is opening downward. And our vertex is right here. And that has the order pair negative 2, 5, which is what we found. And the line of symmetry going right through the vertex, well, that is the line or equation, x is equal to negative 2. Okay, let's look at this one. So it's in standard form. Notice I have a positive here, and also notice I've got a 2 right in front of x, so it's not just ax with a 1 in front of it minus h squared plus k. I have a 2 in front of it. So what I need to do is I need to rewrite it to where I have number 1 a negative and number 2 a 1 right in front of x, or really no numbers in front of x. Okay, so f of x is equal to 4. What I need to do is I need to divide both the terms inside the parentheses by 2. Okay, so what we have here is 4. The 2's will cancel, so I have x. I'm going ahead and make a negative here, which means this would be negative 3 over 2 squared minus 5. Okay, so then our vertex would be negative 3 over 2, negative 5. And our line of symmetry would be x is equal to negative 3 over 2. Okay, so should this vertex be a max or a min? And by the way, on this other one, we had a max for the vertex here. So for this function, notice that I have a positive 4. So that means the parabola should be opening upwards, which means our vertex here is going to be a minimum. And here's our graph of that function. So it is a parabola opening upward. Here is our vertex, and notice that it is halfway between negative 1 and negative 2. So we can write halfway between those negative 1.5 as negative 3 over 2. That's the same thing. And then negative 5. So our vertex is negative 3 over 2, negative 5. And then the axis of symmetry that goes right through the vertex, well, that has the equation x is equal to negative 3 over 2. And also notice that this point right here, the vertex, is also the smallest or the minimum value within the function. Okay, let's look at this one. So it's in standard form. We got a plus value there, so we need to rewrite that as x minus negative 6 squared plus 7. So our vertex is -6, 7, and the line of symmetry is x is equal to -6. Okay, now the number right in front of the parentheses there is, we don't have one, so it's a 1. So it's a positive 1, so we should have a parabola that's opening upward, which we do. Here's a graph of that. And notice the vertex right here is -6, 7. Okay, so that is a minimum. And then the line of symmetry that goes right through the vertex that has the equation x is equal to -6. Okay, well now let's look at, which we've already been looking at, max and minimum values of quadratic functions. The output of the quadratic function at the vertex is the maximum or minimum value of the function, depending on the orientation of the parabola. And the orientation of the parabola is just talking about, does it open upwards or does it open downwards? So notice here, this one is opening upwards. And notice the number right in front of the parentheses is a positive 1. Notice this one is opening downward. Notice the value right in front of the parentheses is a -1, so it's opening downward. If you got a positive, it will open upward. If you got a negative, it will open downward. Okay, so what is the minimum or maximum of this function here? Now notice this is the general form, so we need to use the h value, so that means we need to find a and b. So a is 4, let's see, b is -2, and c is 1. H is -b over 2a, so -2 over 2 times 4, so positive 2 over 8. So take a 2 out, 1 over 4. To find k, I'm going to plug in 1 over 4 into my function. So 1 over 4 squared minus 2 times 1 over 4 plus 1. So this will be 4, 1 over 4 times 4 is 16. Take a 2 out here, take a 2 out here, left with a 2, so -1/2 plus 1. Take a 4 out here, take a 4 out here, I'm left with a 4th. So 1/4 minus 1/2 plus 1. Now I need to multiply this one times a 2 over 2 to get 4. I'm going to rewrite the 1 as 4 over 4, because any number over itself is still 4. So 1, 4 minus 2 over 4 plus 4 over 4 is 1 minus 2 plus 4 all over 4. So 1 plus 4 gives you 5. 5 minus 2 gives you 3, so this should be 3/4. Okay? So our vertex, which is either going to be the max or the min, is 1/4, 3 over 4. Now because this number here, the number right in front of the x squared, is a positive, we know that the parabola is going to open upward like this. If it's going to open upward, this is the vertex, which means the vertex is occurring as the minimum value. Okay, so the minimum value is the vertex of 1/4, 3/4. Okay, now let's find the max or the min of this function here. And again, it's in general form. So we need to find a, b, and c. We can go ahead and find c. -7, +4, and 1. So h is -b over 2a. So -4 over 2 times -7. Notice I have a negative on the top and the bottom. Those will cancel out. Negative divided by negative is positive. So 4 over 2 times 7, so that'd be 14. I can take a 2 out of both of those, and I'm left with 2 over 7. Okay, then to find k, I just need to plug in that 2 over 7 back into the function they gave me. Okay, so this is going to be -7. 2 times 2 is 4. 7 times 7 is 49. Plus, can't cancel anything out, so 4 times 2 is 8 over 7 plus 1. I can take a 7 out here, and here I'm left with a 7. So -4, don't forget that negative that's right there. -4 over 7 plus 8 over 7. I'm going to change this 1 to a 7 over 7. So now I have a -4 plus 8 plus 7. So 8 plus 7 is 15. 15 minus 4 is 11. So 11 over 7. So our vertex is 2, 7, and then 11 over 7. Now, because this number right in front of the x squared is negative, we know that the parabola is going to open downward like this, which means the vertex is actually a maximum. Okay, let's look at this one. So this one is in standard form. So like this way back here. So it is in standard form. So we can, number one, make sure that we have a negative between the x and h, and then we can find our vertex. Okay, so yeah, we do have a negative between the x and h. So our vertex here is 3. Remember, inside the parentheses, you always take the value opposite, comma, 2. Remember, for the k value, you always take whatever they give you, whether it's positive or negative, you take that sign. But for the x, or the number inside the parentheses, is always going to be the sign opposite of what they give you. That's the easiest way for that I've come up with remembering that. Okay, now notice we have a -7, so that means that the parabola is going to be opening downward. Here's our vertex right here, which means that is going to be, a maximum. Okay, now let's look at this one. So we need to find our vertex. Okay, so we've got a positive inside the parentheses, so that's going to be a -2 and -1. This is a positive, so it's going to be opening upward like this, so that means that we have a minimum value for our vertex. All right, let's talk about x and y intercepts for quadratic functions. So if you're going to find the y-intercept, that means that x is equal to 0. So what you would do is you would plug in 0 every time you see an x within the function. If you're going to solve for the x-intercept, that means y equals 0. So you would set the function equal to 0 and then solve for x. So for this one, we're going to find the x and y intercepts for the function 4x squared minus 12x minus 3. So if we're going to find the x-intercept, that means y equals 0. So, and we also know that f of x, that's just a fancy way of writing y. So 0 is equal to 4x squared minus 12x minus 3. Now I can't factor this, so the next thing I would do is I would put it into the quadratic formula. So x equals -b plus or minus the square root of b squared minus 2ac divided by 2a, where our a, b, and c values are 4, -12, and -3. Okay, so we have -12 plus or minus the square root of -12 squared minus 4 times 4 times -3, all divided by 2 times 4. So that will give us 12 plus 144 plus 4 times 4 is 16, and then 16 times 3 is 48, all divided by 2 times 4, which is 8. Okay, this gives you 12 plus or minus square root of 192 over 8. Okay, and then 192